Here we go. Kelvin wave number 1 erupts. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, February 8th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below. And with that, I'd like to thank the folks that donated last week. B. Nadine, E. Slate, and Evolution Moto. Thank you all so much. And with that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting in the North Pacific, remnants of a gale producing 17-foot seas aimed at the U.S. West Coast. Another some sort of a gale producing 26-foot seas or something off of Kamchatka, but not expected to do a whole lot. In the South Pacific, nothing really happening. In the North Atlantic, the star of the show, seas right there, 44.8 feet, the highest seas over this entire domain. There are their locations, and winds 51.2 knots here in a solid gale targeting Europe, with another gale pushing off of the Outer Banks, producing 28, 29-foot seas. All that aimed away from the U.S. East Coast, unfortunately. In the South Atlantic, a small gale with 22-foot seas aimed off to the northeast, but not really doing a whole lot, and a pretty quiet pattern over the Indian Ocean. So we are in winter, but the focus for the moment seems to be the North Atlantic. But first, let's take a look at current conditions. We're going to look at the buoys. We're going to start up north in the Pacific Northwest, Grays Harbor Buoy, 036. They're at the border between Oregon and Washington. We're looking at all the energy that's hitting that buoy all the way up from 33.3 second. That'd be very strong swell energy, which we see 0.0 feet of, the whole way down to 5-second period, just pure wind chop. I see 0.6 of a foot there. But most energy seems somewhere in between the, we'll say 10 to about maybe 11-second period, with little bits of energy trailing off on either side. Using the algorithm, we can determine primary swell 5.3 feet at 11.5 seconds from 254 degrees, producing surf heights of 6.1 feet at your average beach break with no swell enhancing bathymetry. Secondary swell 3.8 feet at 7.8 seconds from 240 degrees, adding another 2.9 feet of basically chop into the mix, or weak wind swell. Heading down to Northern California, same sort of setup. Energy a little bit more, maybe up into the 11 to 12-second period range, but nothing a whole lot more. Primary swell 5 feet at 11.8 seconds from 279 degrees, again making surf at like 6 feet, with his secondary wind swell in the mix 4.1 feet at 8.6 seconds from 273 degrees, adding 3.5 feet of wind swell into the mix. Down to Southern California, the Point Loma South Buoy, number 191 there off of San Diego. Again, the same similar sort of profile, but a little bit more energy. As northerly or northwesterly swells approach the west coast, they hit like the Pacific Northwest first, then down into Northern California, then finally into Southern California. So no surprise, there's a bit more energy in the mix here. Primary swell 3.2 feet at 12.4 seconds from 268 degrees, making surf 4 feet, again attenuated a bit by the Channel Islands. And secondary swell 3.3 feet at 9.1 seconds from 270 degrees, adding another 3 feet of wind swell into the mix. Then finally over to the north shore of Oahu, the Waimea Bay Buoy number 106. Same sort of profile, a little bit more wind swell, a little bit less ground swell, but you get the general idea. Primary swell 5.5 feet at 7.7 seconds from 48 degrees. Yeah, so the wind swell's taking over here. Making surf 4.3 feet, and then here's your semi-ground swell, 3.4 feet at 12.1 seconds from 333 degrees, adding another 4.1 feet of surf. So it's northeast wind swell and northwest semi-ground swell. So where did all this come from? Let's go take a look back in time. We're going back to last week's video, Sunday, the 1st of February. We're looking at significant wave heights. You see a gale here was on the date line producing 22-foot seas aimed south at the Hawaiian Islands and 25-foot seas aimed at the U.S. West Coast. Of course, all that has come and gone. It kind of blew up here on Tuesday, producing 27-foot seas aimed at the Hawaiian Islands. Big swell impacted the islands on Tuesday. Then took aim on the U.S. West Coast with 28-foot seas and well to the south. This pushed swell clearly into Southern California, south of the Point Conception shadow. Also produced swell down into Baja. You can see it approaching the coast there on like Thursday into Friday. Another gale blew up. Let's go back just a little bit here. West of the dateline on Wednesday with 32-foot seas. That thing faded pretty much out. Swell impacted the Hawaiian Islands on Saturday. And then remnants from it produced seas in the 20 to 21-foot range. Swell from that is bound in for California tomorrow. Then same thing, looking back over the past week in the southern hemi, a little gale produced 22-foot seas on late Sunday, the 1st of February, but not of any real interest. But then as we got into Monday night, the 2nd of February, a gale developed 34-foot seas southeast of New Zealand, lifting somewhat off to the northeast, then started attenuating while moving off to the east on Wednesday. Swell from that, not bound for the Hawaiian Islands, but maybe some background energy. We're talking, 2 feet at 14 or 15 seconds, something. Oh, I'm sorry, not even that big. If I recall, 1.4 feet at 14 to 15 seconds into Southern California. But if you're at top spots, you might be able to see a little something from that. That's about 10 days out from, what was that, on Tuesday. And now we're into current time. I mean, given the time of year, yes, nothing else was behind it. So that was kind of a freak little storm. To the North Atlantic, a week ago, there was a big gale off of Europe producing 20, 22, 24, 26-foot seas targeting Portugal down into Morocco pretty well. Another system pushed off the U.S. West Coast. Seas built to 37 feet, 39 feet. This was on Monday into Tuesday. And again, 38 feet on Tuesday, then faded from there. You can see some sort of raw sea state impacted Portugal on it's be early Thursday morning, converting that. 0 hours change on the zero meridian there for those interested in time conversion. This time here, Zulu is the time right at that point. So it's European time, effectively. We got into Friday, another little series of something tried to develop off of Portugal, but nothing too organized. Then Saturday, the first in a series of gales developed with 40-foot seas pushing off the U.S. West Coast, building in coverage as it pushed over the greater North Pacific. Seas 44 feet on Sunday morning. I think that's the last one I have. We had a model problem this morning. I just fixed it, so the new model hasn't posted yet. And then as of early this morning, Sunday, another gale was building off of the Outer Banks with 29-foot seas aimed off to the east. A week ago, on Monday, the 2nd of February, we're now looking at the South Atlantic, looking for anything that might produce some surf, 23-foot seas, almost something there south of Africa. We're all the whole way through the week yet, and nothing solid has developed. That's the latest thing. So pretty quiet in the South Atlantic, as would be expected for the time of year. Then finally, over the Indian Ocean again, Sunday, February 1st. Looking for any sign of 25, 26-foot seas. That's what gets you like a 15-second period swell. We're out Saturdays, the 7th, and here we are current time. And really nothing going on there either. So now we do our deep dive into the North Pacific. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet to the south, sort of like right there. That would create a counterclockwise flow aloft. That is the hallmark of low pressure. That also manifests itself down at the ocean surface. And of course, low pressure, if it's strong enough, generates winds. As winds get traction and impart energy to the ocean, creating seas. The seas radiate away from the fetch area. Lesser period elements decay away, exposing swell. And swell, when it hits like the Hawaiian Islands or California, produces surf. But we really don't have a trough there. It's a split in the jet. So notice the winds pushing off Japan quite strong at 210 knots, making it to the dateline, and then the jet splits with part of it pushing off to the north, part of it pushing to the south. Yeah, maybe some sort of a little trough might be there, but typically when you get this split flow, you end up with high pressure in between. That does nothing for storm production. Off to the east, we do have the jet, remnants of the previous incarnation, the jet pushing up into the Pacific Northwest, generating weather there. California sitting, notice the jet splits again, high and dry, barely under the protection of high pressure here. This is probably the last of it, and a much different pattern is expected to set up for California longer term. So we get into Monday, then you see the split in the jet, a little bit more pronounced. Still good wind energy in the jet. The main energy pushing up to the north dateline region. There is a trough right there. That will help support gale formation. You also notice as we get into Tuesday, a backdoor, we call it a backdoor front. Jet lifts up, then pushes south down the U.S. West Coast, typically dragging colder air with it. Yeah, I know, the end of our nice warm temperatures and precipitation, but that's good. At least we'll get some snow out of it. And you see the trough quite pronounced as we get into Tuesday. Another little bit of a trough still hanging here over the dateline. Wednesday, same sort of pattern. Now notice the jet split there, backdoor troughing it there, kind of a convoluted mess, not great for supporting gale development, and that is probably due to the inactive phase of the MJO setting up down right in here. We'll get into that a little bit later in the presentation. Anyway, into Thursday, still this kind of muddled pattern. One trough there, another trough setting up in the Gulf of Alaska, another trough over Kamchatka. We get into Friday, Saturday, here we go. Another backdoor trough setting up, pushing down the U.S. West Coast, the Jetstream pushing directly onshore over central California, potentially an atmospheric river event, and then you just see a dramatic change in the jet stream from where it was strong, pushing flat across the Pacific to out here. This is like 2 weeks ago, and splitting off California, which gave us the surf that we had. Now a much different pattern in control. So let's go see what effect the jet stream has lower in the atmosphere. It takes winds blowing on the ocean surface to produce swell. So that's what this is, surface level pressure and surface level winds. We see weak remnants of high pressure off of California. A gale currently over the north dateline region producing 45-knot winds, but I think it's lifting north rather quickly and will get very little traction on the ocean surface. Another gale is forecast behind that on Monday with 35 to 40-knot west and southwest winds. Here you go, building to 50 knots as we get into mid-Monday morning. So kind of a split fetch area, 55-knot winds, sort of more aimed up towards Alaska. Tinier fetch of 45-knot winds over the north dateline region aimed at the U.S. West Coast, mainly bypassing Hawaii. Into Tuesday, the gale continues here over the north dateline. Most of the gale is in the Bering Sea, but there is fetch dangling south of the Aleutian Islands. That will get some traction. Another gale develops from that on, let's go, Wednesday morning with 45 to, into Wednesday, 45-knot winds aimed off to the east. This fetch still being somewhat productive as well. That gale lifting northeast rather quick. You notice the pattern is all pushing off to the north now. The previous gale, which was way to the south down here off of Hawaii, which produced surf into California, that pattern long gone by now, and this is like a week out. High pressure in this area, trying to ridge into California, but then here you go, some sort of trough, and let's see, not really a gale, but low pressure in that area, pushing down the coast. We're into Saturday, the 14th of February. Little low pressure over California on Sunday, and then another building one with 40-knot winds behind that. Also notice the gale here with 45-knot winds over the dateline, but again, lifting off to the northeast. This looks interesting from a probably more of a weather production standpoint than a swell production standpoint relative to California. So a pattern that sort of goes up like this and then down here versus one that goes straight across the Pacific. What effect do those winds have on the ocean surface? Let's take a look. Here we are, current time. Remnants of that gale fading in the Gulf of Alaska, swell pushing into the U.S. West Coast. First little fetch produced 28-foot seas, but I don't think any swell is going to result from that. But here comes the next more meaningful one on Monday night into Tuesday, the 10th of February. There we go. What was that? Like 36-foot seas over a very tiny area aimed east. And this, though it's not aimed directly at the U.S. West Coast, probably will get some sideband energy radiating off from that. Little tiny gale off the California coast. Probably doing more to produce weather, if anything. Maybe some energy into Southern California because it is pretty far to the south. Now, again, Tuesday night, you see 20-foot seas filling an area from like well west of the date line into what would be roughly the northwest Gulf of Alaska. That continues as we get through the day Wednesday. Another little gale leading on the front edge here, 33-foot, that is about 33-foot seas. Same deal here. So swell to result from both these pushing into the U.S. West Coast, depending on what the local weather conditions are, whether any of it will be rideable. Another little system off Kamchatka. We've blown that off already. Just doesn't do anywhere. A cutoff gale northwest of Hawaii. All energy aimed off at Japan. Nothing at the Hawaiian Islands. You see here comes the next system falling down the U.S. West Coast on Sunday. That's a week from now, day after Valentine's Day, producing 18-foot seas, but probably more of a weather producer, and then something trying to organize on the date line a week out. Down to the South Pacific for the next week. Looking for any seas greater than, I'll say, 26 feet. That would be about the minimum. The expectation is none should develop and no swell should result. Sure enough, that's the case. Let's move on to the North Atlantic. Now, the suspicion is the inactive phase of the MJO is setting up over the Pacific, given that the Jetstream looks kind of weak and split and all over the place. And the storm track looks much stronger in the Atlantic. Sure enough, here we are Sunday. What do we got? 43-foot seas off of the Outer Banks, aimed off to the east. Another gale there fading off of Europe. Seas down to 28 feet as we get into Tuesday morning. Yep, 30 feet there. This looks good, though. Maybe less jumbled energy into Morocco and Portugal, though Ireland still looks probably pretty raw. Oh, a local gale. Look at that, pushing right into the Bay of Biscay with 36-foot seas on Wednesday. Oh, this would be, late Wednesday night, early Thursday morning, the 12th of February. Batten down the hatches there. It looks like a pretty... probably not a great surf setup. Then moving out beyond that, seems like maybe a quieter pattern. Let's see what this last little bit does here. Yep, not so much. 22-foot seas off of Ireland, maybe producing surf in protected breaks there. To the South Atlantic, a little bit of a gale flares up with 28-foot seas approaching South Africa. Another gale. Looks like it's past the swell window for South Africa. Let's see, there you go. 33-foot seas, 34 feet, but out of the picture when we get to the Indian Ocean section. We'll check that out. You also see tropical activity pushing into Madagascar. Moving out beyond that area of, let's say, 22-foot seas, targeting South Africa on Wednesday into early Thursday, but not doing anything else. Another system with 34-foot seas, trying to traverse the South Atlantic, but not really having the energy to do it, and that was the end of that model run. And finally, to the Indian Ocean. Let's see what we got. There's that one gale. Let's see if it makes it across. Nope, doesn't make it across the Indian Ocean. You do see a bit of a swell front here, so maybe background swell into Western Australia and very minimal energy up into Indonesia. Another gale develops 28, 29-foot seas here, not making a whole lot of north headway. Swell likely for southern Australia into Tasmania. And that was the end of the model run. The local wind forecast for California and Hawaii. Hawaii's right there. You see, as of today, 18Z on Sunday. Pretty much a wind event with east-northeast winds, 20 to 25 knots over most of the Hawaiian Islands. California, light high pressure, a rather light wind regime in control. Oh, Southern California is right in here, Point Conception there. Central California, there's San Francisco Bay, and then the Oregon border is right up here. And you see no real wind barbs, no real wind of any interest. We put this into motion as we get into Monday. 20-knot north winds start developing along the coast, high pressure building in. The wind event continues for the Hawaiian Islands, northwest winds 25 to 30 knots. That's pretty early. There you go, holding all day. Local low pressure building off of California. Trying to get traction, but my guess is that's mainly going to be a precip producer. You see the low itself moving right into the San Francisco Bay Area late on Tuesday. We'll see when we get to the precipitation models if that has any effect on rain. Oh, I'm sorry. And Wednesday over the Hawaiian Islands, moderate trades, 20 knots, so things back off a little bit. Here's our gale pattern developing in the northern Gulf. On Thursday, northwest winds, 15 knots for north and central California. Trades, 20 knots, still pretty strong for the Hawaiian Islands. Friday, again here, high pressure pushing into the coast, northwest winds, 15 knots. Trades, 20 knots for the Hawaiian Islands. Saturday, next low pressure sets up, trough off the California coast. Some sort of more or less lighter wind regime, but that almost looks like southwest winds at 15 knots. Hawaiian Islands trades 20 knots. We can go to Sunday. Here you go. Look at this. Oh, a 1044 millibar high, very strong. Very strong trades for the Hawaiian Islands. Low pressure, pressure gradient. The difference between when you have a high pressure and low pressure in close proximity, it tightens up the isobars. 1, 2, 3, 4. You can just count the number of lines, or you can't. They're so stacked. But that'll be good for producing wind and I guess swell, but it's so close to the California coast, it's just going to be a mess into Monday and Tuesday. Front pushing into California. Here comes the weather machine. Trades continue nuking for the Hawaiian Islands. Precipitation forecast. There is rain over Northern California as of right about now, Sunday evening, but that's all supposed to be clearing out by Monday. But the next low pressure, you see it setting up. Let's go back right here off of California. Rain starting to move into North and Central California. We'll call it Tuesday afternoon. Snow developing in the Sierra. Bring it on. We need it desperately. Wednesday, a weak snow event, and rain continues for California. And they're also, let's check. A little bit of rain here for Southern California Tuesday night into early Wednesday morning. That sort of clears out and fades as we get into Thursday, but we know there's another system coming. Here you go, the leading edge of it into Northern California. Friday night, down to the Bay Area on Saturday. Snow developing in the Sierra. Pretty strong snow, it looks like, as we get into Saturday night, falling south down the entirety of the Sierra. Sunday morning, moderating some rain even into Southern California. And then we're into Monday. More looks like just north, working its way south as well. So a pretty good setup. Finally, the Precip machine wakes up for California. The snow forecast dashboard for Palisades, Tahoe, Olympic Valley, formerly Squaw Valley. You see as we get into the 9th. Let's see. The 8th is today. The 9th is Monday. So Tuesday, you start the blue. You start seeing accumulation, maybe a foot, 14 inches, something like that. But the main event is further out on the 15th, 16th, 17th, and 18th. Theoretically, 60 inches of accumulation. I think that's probably on the high side. That's up as high up on the mountain as you can possibly get. But at least that looks pretty good. Let's go look at Mammoth real quick. Mammoth on a very similar trajectory with maybe 50 or 51 inches total. Let's go look at snow levels. This is the chart for Palisades, Tahoe, but it's pretty good, for the entire Sierra for the most part. This is the base of Palisades, Tahoe, 6,200 feet. The blue line here is the summit up at 9,000 feet. Red would be liquid precipitation if there was precip. Gray would be sleet. The intersection between the gray and the white line is the 32-degree freeze line. You see it once you get past Tuesday. Snow levels fall below the base, barely come up above the base out here on the 12th and 13th. What's that? Thursday and Friday. So 6,500 feet, but it looks like snow the whole way to the top, and then snow levels down at 4,000 feet, if not less, beyond there. So a good temperature regime setting up for incoming water, and therefore good for making snow. But let's go now check this surf forecast for a couple of select locations, starting on the Columbia River, the intersection there between North Oregon and South Washington. Surf heights as we get into Monday in the 10-foot range, fading to 6 feet, down to about 3.5 feet on Wednesday and Thursday, then back up Friday, theoretically 15 feet, dropping to 10 feet, and then holding in the 12-foot range. As we get into Saturday, winds, some version of south, and then offshore Tuesday, Wednesday, still south on Thursday, and then not too bad as you get into the weekend. Let's go take a look at swell heights. 7 feet at 13 seconds, moderating to 3.5 feet at 10 seconds, and back up to 10 feet at 16 seconds, 7 feet at 14, another 8 feet at 15 to 16 seconds. So definitely swell coming for the Pacific Northwest. Down to Ocean Beach, San Francisco, surf heights on Monday in the 6-foot range, building to 7.5 feet in the afternoon, and then Tuesday morning falling from about 8 feet. Notice the south winds at 35 knots, 37 knots, so probably not a surf day at most locations. Wednesday, surf heights in the 5 to 6 foot range, some flavor of south winds. Then winds northwest coming up 20 knots Friday. Surf heights build into the 11 to 12 foot range with light winds early Saturday. And you get the general idea back up on Sunday with some sort of a southwest flow. Swell heights, here we go, fading from 5 feet at 12 seconds, back up to 6 feet at 14 seconds. This would be Tuesday morning. Wednesday, 4 feet at 11 seconds, just generally knocking down. Then swell heights come up 7 feet at 14 to 15 seconds on Saturday, and 8 feet at 16 seconds on Sunday. Down to San Diego, surf heights in the 3-foot range Monday, Tuesday, maybe picking up a little bit in 5 foot on Wednesday, probably wind swell. 3 feet on Thursday, and then pretty much dropping out after that. The wind situation, not too bad. I don't see any 30-knot winds at least. Let's go take a look here. 2.5 feet at 11 seconds Monday, 2.5 feet at 13 seconds Tuesday, 4.5 feet at 11 seconds on Wednesday. That's probably the cold front coming through. Thursday, then everything kind of drops out. 2 feet at 9, 10 seconds. A little bit of energy, 2 feet at 14 to 15 seconds on Saturday and Sunday. Over to the north shore of Oahu. Oh my gosh, look at the trades here. 20, 35, 33 knots and east-northeast. I mean, just a solid block the whole way across. At least it's down to 18 knots at one point, but surf heights, okay, 4 feet dropping to 2 feet. A little bit of energy out here on Friday, 8.5 foot surf. Still strong trades. Let's go take a look at these swell heights. Monday, 3.9 feet at 11 seconds, slowly dropping, not a whole lot. 2 feet at 15 seconds on Wednesday, up to 5 feet at 15 seconds on Friday. So that's probably your best swell for the foreseeable future. Over to Ireland, a generic town on the central Ireland coast. Surf heights 20 feet on Tuesday morning, dropping off a little bit, up to 26 feet on Wednesday in the 20-foot range on Thursday, then dropping down from there. During these events, some sort of south winds 20 knots on Tuesday, and then really not a whole lot of wind during this larger peak here. Winds coming up out of the north, 28 knots on Friday, so you can kind of generally see it and figure this out for yourself. Then finally, central Portugal, you know the spot. Surf heights 23 feet on Tuesday, Wednesday 24.6 feet, and then fading a little back up to 20 feet on Saturday, fading from there. Winds onshore Tuesday, onshore 20 knots Wednesday, northwest at 25 knots on Friday, so a bunch of onshore winds. but just for fun. Swell heights 12 feet at 17 seconds. That would be on Tuesday. Wednesday, 15 feet at 16 seconds. I mean, there's plenty of energy in the water. Just need a little less wind. 16 feet at 12 seconds on Friday and dropping out from there. All right, let's go take a look at the long-term outlook. We're going to examine the two major weather oscillations that affect the potential for surf and rain into California. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're going to start by talking about the MJO, the Madden-Julian Oscillation. It is a weather oscillation in which two phases, the active phase and the inactive phase, they rotate around the planet basically opposite each other. On the equator, moving west-east, one on one side of the planet, the other on the other side. They rotate around the planet like that. Again, west-east. The active phase is our friend. It is a low-pressure system. It takes warm, moist air at the ocean surface, lifts that aloft up into the upper atmosphere. That warm, moist air feeds energy into the jet stream, making it stronger, and consolidates it. A stronger jet is better at digging out troughs. It doesn't split, and therefore making surf. A weaker jet splits, it gets fragmented, sort of like what you've seen over the Pacific. So one can assume, just given that we probably are in the inactive phase over the Pacific. The Atlantic, again, with the stronger jet stream, you see more storm production there, just like what we've been looking at. The active phase is probably over there, moving west-east. So the active phase has probably moved from the Pacific. That's what gave us all our surf last week. Now making its way into the Atlantic. The inactive phase is setting up over the Pacific Ocean, and the jet stream is getting weaker. That's just from looking at the the wave models and sort of looking at the pattern. But let's confirm that. We're going to go look at the TAO buoys, a series of buoys strung across the equator in the Pacific. This would be the East Pacific. This is the West Pacific here. These buoys are used for monitoring El Nino. They have sensors down their anchor lines, and you can see warm water moving around subsurface. But we're going to examine, they also have wind sensors on them. So you can just look at the arrows here. 5-day average winds. The longer the arrow, the stronger the wind. So moderately strong trades out of the east, somewhere over the East Pacific, a little turning to strong over the Central Pacific, strong over the dateline, and into the West Pacific. This is where all the magic happens. This is the far West Pacific here. That's New Guinea there. There's the dateline. From as far west in the Pacific as you can get to about 170 west. When you get the active phase over here, that's really good for pumping energy into the jet stream. Then the jet stream pushes downstream over the Gulf of Alaska and into California and produces surf. Easterly anomalies steal energy from the jet. Again, it's like that's the sign of the inactive phase. The inactive phase of the MJO is like a high pressure system. It has falling air in it that cuts off the flow of energy to the jet stream. The jet stream gets weak, and because it's high pressure, it marries up with the normal high pressure patterns that are over the Pacific, making trades stronger than normal. And you can see that from all this area here. So likely inactive phase in control, but that's just average winds. It's not the actual winds that matter. It's the anomalies. Are they stronger or weaker than normal for this time of year over that particular portion of the Pacific? You see over here in the West Pacific, in the East Pacific, trades are effectively reversed. So active phase may be exiting, moving out this way. This is 5-day average winds too, so this is probably what happened 2.5 days ago. My guess is you probably have actual normal trades here now. In the Central Pacific, trades a little bit stronger than normal, and a little bit pretty much almost normal here in the far West Pacific. But my guess is that is going to change. Let's go see, let's do a retrospective of the past 5 days, the wind anomalies. So this chart just depicts the 850 millibar wind anomalies. That's up. This ocean surface is like 1,000 millibars. 850 millibars is up. That's about 4,700 feet. Okay, South America, Central America, Hawaii's up in there. There's New Guinea there. 0 is the equator, and the date line is right there. The far West Pacific right there, north of New Guinea. And our main area right here from 170 west to about 125 east, 5 degrees north and south of the equator. You see easterly anomalies, the blues, the winds arrows pushing out of the east. Little bit of westerly anomalies still here in the far west Pacific. These are actual storms or systems. Again, the magic is 5 degrees north and south of the equator, not further up. Okay, that was on February 2nd, the 3rd, same thing, the 4th, the 5th. Really no particular change, a sort of a mix, like the north part of the equator, a little bit of westerly anomalies, the south part, a little bit of easterly anomalies, but nothing too particularly strong. Let's go take a look at some forecasts. Outgoing long-wave radiation forecast. That's just fancy words for cloud cover. If you have the active phase of the MJO and it is a low-pressure system, takes warm, moist air, lifts it up into the atmosphere. That warm, moist air hits the cool upper atmosphere, condenses, makes more clouds than normal. Inactive phase of the MJO does the opposite. It's falling dry air, so you would get no clouds, a lot of sunlight reflectivity off the ocean surface, outgoing long-wave radiation, so positive values, and cloud-free skies, that's the inactive phase of the MJO. So South America, Central America, New Guinea, the equator running right along there, dateline 180 west right there. This suggests, this model, the statistic model says, above normal outgoing long-wave radiation. Drier than normal air, clearer than normal skies, the inactive phase of the MJO. Same thing 5 days from now, 10 days from now, 15 days from now, with the active phase of the MJO officially in the Indian Ocean building there, getting stronger, maybe trying to seep into the West Pacific 15 days from now. Let's go look at the dynamic model, the GFS model. Oh my goodness, this shows a much worse situation, inactive phase, far stronger and moving nowhere over the next 2 weeks. No big surprise, but the active phase building ever stronger in the Indian Ocean. The last frame of the statistic model, the last frame of the dynamic model. My guess is the dynamic model will moderate some. The statistic model will increase some, and we'll end up somewhere with a moderate to strong inactive phase of the MJO 2 weeks out from now. Let's go look at more models. But first, let's do the phase diagrams for the same two models, statistic model, dynamic model. What does this chart show? It just shows you where the active phase of the MJO is, where it's forecast to be 2 weeks from now, and how strong it is. How do you read the chart? Active phase moves from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, over the Atlantic, over Africa, back to the Indian Ocean. They rotate around the planet, west to east. The heavy dot is where the active phase is. If the closer to this circle you are, the weaker the active phase is. So an extremely weak active phase of the MJO in the far west Indian Ocean. The forecast 2 weeks from now has it still in the East Indian Ocean and extremely weak. The dynamic model says the active phase building to moderate strength, still basically in the same position in the far East Indian Ocean, not even to the Maritime Continent yet. This does not look good for feeding energy into the jet and for supporting gale development in the Pacific for the next 2 weeks. But the silver lining is, if the jet is really weak, that allows this backdoor trough scenario to set up and allows cool air from the Arctic to push south down the U.S. West Coast, producing precipitation. The flip side of that is, if you have a strong active, well, a medium active phase, which is sort of what we just had, the jet stream reaches right up to California, but doesn't have enough energy to penetrate high pressure over land, and so you get no precipitation. Everything ends up in the Pacific Northwest. And then if you have a super strong active phase, then the jet stream just plows right into California, or into full-on atmospheric river event, and, sometimes doom and gloom in terms of precip and storms and wind and all that sort of thing. All right, let's look at some models. The GFS model, our standard old regular weather model, goes out 2 weeks. This is 850 millibars zonal wind anomalies. Are the winds stronger or weaker than normal? Up at 4,700 feet. Good proxy for what's going on at the ocean surface. This is for the entire planet, not just the Pacific. So the date line, right up the middle of the chart, far west Pacific starts at 125 east, so right here. So here is the oranges and yellows and reds, westerly anomalies. This looks like the active phase of the MJO that pushed across the Pacific into the end of January, setting up our stronger jet streams, setting up surf. And then that started collapsing as we got to the end of the January. Here we are, the last little westerly anomalies barely hanging on in the far west Pacific. And then here's where we go. These are in 5-day increments, so a week from now and then 2 weeks from now. Easterly anomalies building pretty strong over the dateline region and Kelvin wave generation area of the West Pacific. West anomalies building over the Indian Ocean towards the maritime continent. Here's the dividing line right here. Cannot get a single toe in the door except maybe the last day of the model run. So this looks like active phase pushed across the Pacific here. Now the inactive phase is setting up, and then another active phase potentially behind that. Let's keep going. All right, here's the CFS model, a dynamic model but optimized to go out long term. It actually shows the MJO, the solid contour here. So here is a weak active phase back in November. The first active phase of the MJO in months and months. It actually produced a Kelvin wave, warm water pushing east. We'll get into that in a minute. Inactive phase set up from November the whole way through December. Remember how there was literally no surf in December. The worst December pretty much on record. Then as soon as we got into the new year, here comes the active phase. It's set up. The reds producing westerly anomalies. We even had a little bit of an interaction with an Equatorial Rossby wave. That goosed up the active phase even more. That set up our current surf setup. Now notice this died January 4th, but the Jetstream still had the momentum in it and spit out that storm that we just got and the swell that I think it's still actually kind of hitting northern and southern California. But here, dotted contour, inactive phase set up over the next 1, 2, almost 3 weeks. And then past that, here we go, active phase, 2 contours setting, building up to, there's the date line. So you get the general idea, active, inactive, active. The good news here is at least we have a pattern. All this past year prior to November, there was literally no MJO. There was nothing to force anything to happen in the atmosphere. The southern hemisphere was asleep. We had a very lackluster summer. We had a very lackluster fall until we hit November, and then things tried to wake up. And so now we're moving into not El Nino at this point. I'd say we're just transitioning towards ENSO neutral, a normal sort of pattern. Let's keep going. The CFS model going out 3 months, but the forecast is on the top, past performance is on the bottom. Again, the date line runs right up the middle of the chart. These are westerly anomalies and easterly anomalies. Let's see, far west Pacific starts right there, 125 east. So here was our westerly anomalies. They actually sort of look at it like that direction, and that direction. That's west-east over time. So as you're moving forward in time, there was the first weak active phase of the MJO in November. There was our inactive phase in December. Here was the past active phase that literally today is just falling apart. Then here is the inactive phase from now to about on the date line till about March 4th. So let's say 1, 2, 3 weeks. But notice westerly anomalies steadily creeping into the Kelvin wave generation area starting about 10 days from now. So really, the next 10 days are probably the time to go take care of business, and then maybe things will start waking up as we get later into February and March. Look at this. At least it's projected the strongest westerly wind burst of the 1, 2, 3 so far. And after that, westerly winds completely take over the date line on through the end of the period. This would be May 8th, roughly. This has been long forecast, the building of, or the switching of a pressure pattern in the Pacific. Also notice easterly anomalies building over the maritime continent. Last year, you can see it even here in October. Easterly anomalies over the dateline. The westerly anomaly pattern was over the maritime continent. That's La Nina. This all switches here, theoretically going to some flavor of El Nino. Let's overlay the MJO here. Okay, here you go. Here's our current active phase fading out. The inactive phase just now starting to build far west Pacific, 125 east. So just now starting to build in the far west Pacific. We got to suffer through about 2 weeks, a week and a half. But then you see, as we get, even a week and a half out, westerly anomalies start again building. Active phase starts building strong. And then after that, we're off to the races. Theoretically, if you want to believe a model that goes out 3 months, it's hard to believe a model going out even 2 weeks. But this has been on the charts for a long time now. Again, here's 1, 2, our third active phase of the MJO. This is the push towards, theoretically, some flavor of El Nino with more happening subsurface in the ocean. We'll get into that in just a moment. So the trades are the trades and anomalies are anomalies, but they don't just affect the ocean surface or right above the ocean. They affect the movement of water under the equator down 150 meters, and we're going to see that in a minute. This is the far west Pacific, New Guinea. This is the far east Pacific, roughly Ecuador. We're looking, and these little lines here, these are the anchor lines on the buoys. The X's are the sensors on those anchor lines. The sensors tell us what water temperatures are subsurface. You use a model to fill in the gaps in between the buoys, and you get a profile of what warm and cold water is doing over time. All right, the 30 degree isotherm, that's warm. This is centigrade, 30 degrees centigrade, quite warm water, about where it was last week. The leading edge at 165 east. The 29 degree isotherm unchanged from last week. The 28 degree isotherm unchanged from last week. The 24 degree isotherm, though, it's about like where it was, but now we have 25 degrees centigrade anomalies building. The suggestion here is that warmer water is building here. We're going to see why right now. Here, it is not the actual temperature, it is the anomalies, the differences from normal. 4 degree centigrade anomalies, again, down at the isotherm, 150 meters below. If you have westerly anomalies in the far west Pacific, they will take warm water that's in the shallow islands of the maritime continent, start dumping it into the west Pacific. That water will start moving right in a narrow band, 2 degrees north and south of the equator, the whole way across the Pacific. Once the westerly anomalies start building, it takes 3 to 4 months for that warm water to go from here to here. One of those Kelvin waves is already reaching. This is the one, the Kelvin wave from November is erupting now. Yes, we believe it is erupting. I'll show you the receipts here in a second. Off of Ecuador. Kelvin wave number 2, making its progression across the Pacific. And if the active phase of the MJO sets up as forecast 2.5 weeks from now, Kelvin wave number 3 might be on its heels. Right, that's one set of data. Let's go look at the GODAS information. There's Kelvin wave number 1 erupting between, this says 120 west to about 83 west, something like that. So when we go look at the subsurface or the surface temperature charts, we'll see it. Kelvin wave number 2 over the date line with temperatures down pretty far down, 5 degrees below, above normal, and hopefully more behind that. Let's go look at one other chart. This is sea level anomaly data, not temperature. It looks like temperatures, but it's not. It's the height of the ocean surface. We're looking, is the sphere of the ocean or of the globe higher or lower than normal in certain places over the oceans? Why would that matter? Well, if you have cold water at depth, let's see there, cold water contracts. When it does that, you'll end up with a divot on the ocean surface. Warm water expands. When it does that, it pushes the water up above it, creates a bump on the ocean surface. So let's look at our chart here. Here is South America, Central America. There's the equator. There's the date line. There's New Guinea there. On the equator, look at this. We got positive anomalies, not huge, but up to 5 centimeter anomalies the whole way from, and even higher, from New Guinea, the whole way just poised. There's the Galapagos there, poised to hit Ecuador. In fact, there's some positive anomalies along the coast here, suggesting maybe warm water is already starting to hit there. That's a very good sign. Upper ocean heat anomalies. This sort of puts it all together. There's time. This goes back a year. West Pacific is here. Far East Pacific here, right at Ecuador. So there was last year's La Nina. We had a little warming last summer, but nothing. Here was this winter's La Nina. A little pulse there in July, another little pulse in September, another little pulse in November, but we had the active phase over here. There was the beginning of warm water moving off to the east. Currently, this suggests it's to about 92 west, just off the, probably pretty much right at the Galapagos, with warmer water pushing over the date line. This is a very good scenario suggesting, remember last winter, we had cold water the whole way through till March on the equator. Now we have warm water spilling over. This is a good sign. Sea surface temperature anomalies for the whole planet. I'm not even going to look at the fact that literally everywhere you look, and this is corrected data, you know, trying to wipe the global warming signal out or climate change, whatever you want to call it, showing basically everything warmer than normal. All that said, here is South America, Central America, New Guinea, the equator right there, dateline right there. Here is the last fading remnants of our La Nina cool pool. Now remember, this is on the surface. Those warm waters that we were looking at subsurface, they're down 150 meters going, again, 2 degrees north and south of the equator. So they're tracking west to east. The leading edge is probably erupting somewhere, what did we say, between like 90 and 120. Oh, look at that. There's warming in that entire area right there. Now also notice there's warming off of Chile and off of Peru as well. And the last little cool pockets, the really cool pockets are, I've noticed a steady decline now in the past couple days. The aerial coverage of the cool pool is declining. Now, that said, we have the inactive phase of the MJO setting up. Trades are going to blow stronger. There will be upwelling, and this will persist. But that is completely irrelevant to what is happening subsurface. There is an ocean of warm water pushing off to the east, starting to erupt here. This warmer than normal water will get caught by the trades and start getting dragged into this area. Even if there is upwelling, this warm water will moderate that upwelling effect, and little bit at a time, this is all going to start just disappear. Let's go look at the change over the past. Oh, let's actually go look at an alternate version of this. This uses, instead of some absolute value, just says, okay, what's the average temperature of oceans around the entire planet, and then compare the variance grid by grid square over the whole planet. Here's your cool pool, a little bit bigger, but even it is decaying on this chart. This is a very conservative view. The other chart is a very liberal view, but you work with what you have to work with. And here is the money shot. The sea surface trend for the past 7 days, and what I immediately noticed, look at the upwelling here between Ecuador and the Galapagos, and then warmer there, notice between about 125 and 83. I believe this is the first finger of the Kelvin wave number 1 produced by the active phase of the MJO back in November, starting to erupt. So if it happened in November to December, January, here we are, February, 3 months later, it's erupting right on schedule. In fact, again, here is the Kelvin wave reaching the surface between 120 and about 84 west. And here's what I believe the actual evidence of that warm water reaching the surface between 83 west and 125 west. So a building area of warm water here on the surface, and the expectation is that is only going to grow over the coming weeks and months. Here is the sea surface temperature trend in the Nino 1.2 region. This area is right there by Ecuador and the Galapagos. Temperatures reaching up just a little bit, 277 thousandths of a degree above normal in the past 3 days. That's a quarter of a degree, no big deal. But that's way better than being down 1 degree or more. And the expectation is this is going to continue to go up. This is the leading indicator. Noisy, not completely reliable, but given what we know is happening subsurface, I think this is going to go nowhere but up over the coming weeks. Now notice in the official El Nino region, the Nino 3.4 region, no major upward trend. Yeah, maybe a quarter degree, maybe a half a degree since January 11th, because the Kelvin wave has to erupt in the east, then get caught by the trades and blown over the central Pacific. This is the Nino 3.4 regions from a point south of California, 120 west, out to about the dateline, 170 west. Temperatures today, 828 thousandths of a degree below normal, so a little bit below 3/4 of a degree. Neutral is plus half a degree to below half a degree. Weak La Nina is half a degree to 1 degree, so we're in that range, but that quickly, I suspect, is going to get wiped out. What does the atmosphere think is going on? Well, if the Kelvin wave, the first Kelvin wave in a series, is just erupting today, my guess is the atmosphere has no clue what's going on. This eruption thing's going to have to go on for probably 3 to 4 months before the atmosphere will even start to figure out what's happening. That doesn't mean that active phases of the MJO will not impact the atmosphere, but from a very broad perspective, from, the atmosphere turning towards an El Nino pattern, that's a minimum 3 months out and probably more. This is the Southern Oscillation Index, difference of pressure between Darwin, Australia, and Tahiti, Darwin over the maritime continent, Indian Ocean, Tahiti over the central Pacific. When pressure is lower over Tahiti, then at least the active phase of the MJO is in control, and that's what we want to see. Today's value, 0.05. We were at -2. I mean, that's nothing. So basically neutral. We were pretty positive here for a week or so. The expectation is this is going to continue to climb as the inactive phase of the MJO builds over the Pacific. So this could be as simple as local low pressure over Tahiti for a couple of days. 30-day average, this gives you more kind of you can see the swings in the MJO. If it's falling, it's the active phase of the MJO. If it's rising, it's the inactive phase. Today's value, 10.91. Where were we? We've been pretty high. Where have we been for the past month? Well, we were at 5.66. I'd say this is pretty much steady for right now. The 90-day average is your El Nino, La Nina indicator, 6.49. Where were we a month ago? 7.76. So basically rock solid, somewhere in the weak La Nina-ish pattern. Again, I don't think our Kelvin wave and all this other stuff is going to have a significant impact on this guy for at least another 90 days. Let's look at the data on a chart. All right, so here we go. Let's see. You can see neutral is considered +7 to -7. Where are we today? This says +12. This is the 30-day average. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase. I'll expect this to go up again before we hit that new active phase out 2 weeks from now. But then even at that, remember, this all depends on Tahiti, and Tahiti's at like 140 west, so it's like half to 2/3 of the way across the Pacific. So this is definitely a major lagging indicator. That said, at some point it will be dropping. Where was our last El Nino? Back in here, I think, it was actually off the charts. It was in 22, 23. And that El Nino was kind of a fake El Nino, and that's kind of what we're going to talk about now. But first, sea surface temperature anomaly projections from the CFS model for the Nino 3.4 region. CFS model maybe overhypes it a little bit, but you can see here regardless, sea surface temperatures forecast rising dramatically from here forward. That's January 15th, so February 15th would be somewhere right around there. This looks like it's going to be in the end of February, early part of March. Officially, sea surface temperatures will be dead neutral. That blue pocket in the central equatorial Pacific will be gone. And then we're off to the races from there. Now, this is overhyped. Another version of the model says temperatures only 1.25 degrees. That's in October. So this is, we're talking 6 months out or more. But you see what the general trend is. And when the consensus model came out last month, it hinted at something like this. Not as strong as this, but it hinted at it. But this model here, I think, tends to have a jump on everything else. It senses trends before all the other models do. So for right now, Jetstream splitting over the Pacific, kind of getting a mess. The storm track, forecast to track well to the north. Locally for California, that's good though. Backdoor troughs pushing down the coast. Some semblance of precipitation and snow is forecast. The snow resorts desperately need snow, so bring it on. I didn't really look at where we are precipitation-wise as compared to a whole normal year, but I think we're probably at about 75% of normal right now and dropping every day. But with incoming precipitation, that will only be good. I mean, the reservoirs are all in pretty good shape, so I'm not too worried about that. It's snowpack and then that, tamping down the fire concern for later this summer. So all looking good. Inactive phase of the MJO, we need to suffer through it. We're back in a normal pattern now. Active phase, inactive phase, cycling back and forth, but a strong active phase forecast starting about 2 weeks out, something like that. The latter part of February into March is going to get very interesting as the MJO builds. Oh, we never even did show the charts. I'll do it real quick. The charts here for the low pressure bias. Again, okay, date line is running right up here. Here's the low pressure bias. Here's our active phase of the MJO. It's going to drag the low pressure bias over the Pacific, over the date line by mid-March, and then full-on regime change sets up with 3 isobars of low pressure over the date line, where versus in October we had 2 high-pressure isobars or contours over the date line. Also, again, those easterly anomalies building over the maritime continent, low pressure building over the Pacific. The point being, a pressure change likely setting up. The next active phase of the MJO is going to be key into forcing that, with westerly anomalies pushing the whole way across the Pacific. That says, come later, like starting maybe 2.5 weeks out, winter in earnest will really set up, because the Pacific is going to completely change its configuration, driven by the MJO, the long-term pattern. The MJO leads the pack, driving active phases. That sets up Kelvin waves. That sets up westerly wind bursts. That creates Kelvin waves, warm water pushing across under the Pacific to Ecuador. It erupts off of Ecuador. That starts filling the Equatorial Pacific. The trades drag those warm waters the whole way across the Pacific, and then that's what starts setting up El Nino. It is strong, consistent, active phases of the MJO. So, and when those happen, the jet stream gets stronger, and then we get better surf pattern. The suspicion is, if I believe the CFS model, and that's kind of a tough bet, but that something significant is going to change, and that we're going to have winter. It's going to be a late winter, not an early winter. But something significant is going to change as we get to the 1st of March, and it's going to be like the dead of winter in March and maybe even into April. And maybe spring will just sort of not really happen. And certainly not maybe that strong high-pressure nuking north wind type event down the California coast, because we'll be in the throes of winter. It's going to be interesting to see how this is going to play out. Let me know your thoughts. All right, longer term, though, it looks like potentially some flavor of El Nino as we get into the fall. That should bode well for our summer, with the active phases still pushing across the Pacific. Theoretically, maybe driving, again, they drive the jet stream not only in the northern hemisphere, but also in the southern hemisphere. Not quite as tight a correlation there, but that could bode well for our summer starting to get progressively better, probably starting out slow, but building and then better later in the season. So again, we'll have to see. Then once we get to fall next year, things are going to be very interesting indeed. All right, that's our forecast for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question or an opinion, write it up down below. All are welcome. And if you'd like to make a small contribution to the cause, and we do appreciate it, you may hit the super thanks button down below. Again, thanks to all the contributors over the past year. You keep this thing going. You keep me motivated to keep doing this. And I really want to say, just looking right at you, thank you very much. All right, that's it for this week. We will do it again next week, same time, same channel. Thanks so much for watching.